A wonderful day, grade 9 students! Welcome to Valenzuela Live Science 9, where learning is fun. Are you ready for today's fun-filled learning experience? But wait, before we begin, let me give you some reminders to observe during our live discussion.
Use your real name. Choose a workspace that is suitable for learning. Take down notes during class. Use the comment box appropriately. And respect one another.
Now, please get your learner's module in science, your pen, and notebook. If you're ready, let's begin with a review of your past lesson. We will play a game entitled Complete Me. In this game, you will choose what word will complete the sentence correctly. You have 10 seconds to type your answer in the comment section. Are you ready? Let's start.
Momentum is measured by the blank of mass and velocity. Is it sum or product? Type your answer now. Time's up. The answer is product. Next. Blank is the change in momentum. Is it impulse or collision? Type your answer now. Time's up. The answer is impulse. Next. All the momentum in the objects before the collision is blank to all the momentum in the objects after a collision. Is it equal or different? Type your answer now. Time's up. The answer is equal. Did you get all the correct answers?
An amazing grade 9 students! Now, let us proceed to our learning objectives. For today's session, you are expected to distinguish between potential and kinetic energy, explain the law of conservation of mechanical energy, and analyze the conversion of potential to kinetic energy and vice versa to given situations. Exciting, right? But before we start, let's play another game entitled Guess the Word. In this game, you will be going to identify the word or words being described by each statement. You have 10 seconds to type your answer in the comment section. Are you ready? Let's start.
It is defined as the capacity to do work. Type your answer now. Time's up. The answer is energy. Next. It is the changing of energy from one type to another. Type your answer now. Time's up. The answer is transformation. Next. It is the energy acquired by objects upon which work is done. Type your answer now. Time's up. The answer is mechanical energy. Did you get all the correct answers?
Good job, grade 9 students! Now, let us talk about energy. Energy is all around us and exists in many forms. We can see energy as light, hear it as sound, feel it as heat, and even taste it by the food we eat. Energy is defined as the capacity to do work. Energy is found in different forms and can transfer and/or transform. Energy can be transferred without being transformed. It can also be transformed without being transferred. It can also be transformed during transfers. In general, the energy acquired by objects upon which work is done is known as mechanical energy. Energy has two basic categories: potential and kinetic energy. Potential energy is the energy in matter due to arrangements of its parts, composition, location, and structure. It is commonly considered as stored energy or energy at rest, having the potential to do mechanical work. For example, a pile of books on top of the table has more ability to do work than the same pile placed at ground level. Thus, potential energy depends on the height of an object relative to a reference point. The various forms of potential energy are gravitational, chemical, elastic, nuclear, and electrical energy. On the other hand, kinetic energy is the energy in moving matter and waves. This type of energy is possessed by an object in motion. For instance, a car in motion possesses kinetic energy whose amount depends on the car's mass and speed. Kinetic energy also has various forms, such as motion, heat, or thermal, radiant, sound, and wave. Let's see if you understand the difference between potential and kinetic energy. Type PE if the scenario shows potential energy, and KE if it shows kinetic energy. You have 5 seconds to type your answer in the comment box. Are you ready? Let's start.
A child sitting at the top of the slide. Is it PE or KE? Type your answer now. Time's up. The answer is PE. Next. A student riding a bicycle. Is it PE or KE? Type your answer now. Time's up. The answer is KE. Next. A ripe mango in a tree. Is it PE or KE? Type your answer now. Time's up. The answer is PE. Next. A yo-yo before it is released. Is it PE or KE? Type your answer now. Time's up. The answer is PE. Next. Water falling from the falls. Is it PE or KE? Type your answer now. Time's up. The answer is KE. Did you get all the correct answers?
Good job, grade 9 students! Now, let us talk about how we can identify the mechanical work done by the potential and kinetic energy by using the following equations. For potential energy, we will use the equation PE grav equals mgh, where PE grav is the gravitational potential energy, m is the mass of the object, g is the acceleration due to gravity, that is 9.8 meter per second squared, and h is the height or elevation difference. Let's have an example. A 0.5 kilogram ball is about to roll off the edge of a 1.5 meter tall table. What is its current potential energy? First, let us write down the given. M is equal to 0.5 kilogram, h is equal to 1.5 meters, and g is 9.8 meter per second squared. We are asked to look for potential energy. Next, write down the formula. PE grav equals mgh. Let us substitute the values of the given to our formula. That will give us PE grab is equal to 0.5 kilogram times 9.8 meter per second squared times 1.5 meters. The answer will be 7.35 joules. Take note that the unit for energy is joule. To calculate the potential energy of elastic objects, we can use the formula PE_elas equals 1/2 kx squared, where PE_elas is the elastic potential energy, K is the spring constant, and X is the compression or extension length. Let's have another example. A stretched string has a total length of 0.6 meter and a spring constant of 240 Newton meters. Calculate its elastic potential energy. Write down the given. K, or the spring constant, is equal to 240 Newton meter, and X, or the extension length, is 0.6 meters. We are asked to solve for the elastic potential energy. Let us use the formula PE_elas equals 1/2 kx squared. We can change 1/2 to 0.5. Then substitute the given values. The answer will be 43.2 joules. We can also calculate the kinetic energy by using the formula KE equals 1/2 mv squared, where KE is the kinetic energy, m is the mass of the object, and v is the velocity of the object. Let's have an example. Determine the kinetic energy of a 630 kilogram roller coaster car that is moving with a speed of 20.3 meter per second. Write down the given. M is equal to 630 kilogram and V is equal to 20.3 meter per second. We are asked to solve for the kinetic energy. Let us use the formula KE equals 1/2 mv squared. We can also use 0.5 instead of 1/2 for easy solving. Substitute the given values and solve. The answer will be 129,808.35 joules, or we can express it in scientific notation. That will give us 1.29 times 10 raised to 5 joules.
Now it's your turn. Try to solve this problem. Calculate the kinetic energy of a 900 kg compact car moving at a velocity of 20 meter per second. You have 30 seconds to answer, and your timer starts now. Time's up! Now, let us check your answers. The correct answer is 180,000 joules, or 1.8 times 10 raised to 5 joules. Did you get it right?
Good job, students! Now please take a look at these pictures. How would you describe the transformation of energy in these pictures? Correct! The chemical energy from batteries was converted to light energy. But how about in these pictures? How does the energy transform? Correct! The light energy from the sun was converted to chemical energy by the plants in the process of photosynthesis. Those are the examples of the law of conservation of energy, which states that energy is transformed from one form to another. Energy is neither created nor destroyed, and thus, energy has always existed in one form or another. Also, according to the law of conservation of mechanical energy, in a closed system where nothing leaves or enters, the total mechanical energy is conserved, meaning the energy is constant. There will be no gaining or losing of energy unless work is done on the system or external forces are acting on the system. We can mathematically express it in this equation. MEI equals MEF, where MEI is the initial mechanical energy and MEF is the final mechanical energy. To further explain this, observe what happens in the roller coaster. How does the energy transform and conserve? When the coaster is at the top and at rest, its potential energy is at its highest value, and its kinetic energy is zero. As the coaster starts to move down the track, its potential energy is transformed into kinetic energy. It gradually gains its kinetic energy while gradually losing its potential energy. The total mechanical energy produced by the potential and kinetic energy at the top of the roller coaster and the total mechanical energy at the bottom of the roller coaster is the same. We can mathematically express this in the equation TME equals KEI plus PEI equals KEF plus PEF, where TME is the total mechanical energy, KEI is the initial kinetic energy, PEI is the initial potential energy, KEF is the final kinetic energy, and PEF is the final potential energy. Now, let's see if you understand our lesson. Let's play a game entitled Quiz It. In this game, you will choose if the correct answer is in letter A or B. You have 10 seconds to answer each question. Type your answer in the comment section. Are you ready? Let's begin.
The roller coaster at the top of the track possesses A. High potential energy and zero kinetic energy, or B. High kinetic energy and zero potential energy. Type your answers now. Time's up. The answer is A. High potential energy and zero kinetic energy. Next. As the roller coaster moves down the track, what happens to its potential and kinetic energy? A. The potential energy will increase while the kinetic energy will decrease. Or B. The potential energy will decrease while the kinetic energy will increase. Type your answers now. Time's up. The answer is B. The potential energy will decrease while the kinetic energy will increase. Next. What happens to the total mechanical energy of the roller coaster after it goes down the track? A. The total mechanical energy will increase, or B. The total mechanical energy will be the same. Type your answer now. Time's up. The answer is B. The total mechanical energy will be the same. Did you get all the correct answers?
Amazing, grade 9 students! Always remember that energy is defined as the capacity to do work. Mechanical energy is the energy acquired by objects upon which work is done. Energy can be classified as potential and kinetic energy. Potential energy is the energy at rest, while kinetic energy is the energy in moving matter and waves. The formula for solving potential energy is PE grav equals mgh, or PE ls equals 1/2 kx squared. The formula for solving kinetic energy is Ke equals 1/2 mv squared. The law of conservation of energy states that energy is transformed from one form to another. Energy is neither created nor destroyed. The law of conservation of mechanical energy states that in a closed system, the total mechanical energy is conserved. Thank you, grade 9 students, for watching today's session in Valenzuela Live Science 9. I hope you learned and enjoyed this session. This is Miss Lalita Cornelius, your science teacher. Take care and God bless everyone.